Okay, in this CRO screen, for example, we have a different divisions here. The total screen is divided into number of divisions, and each division, it is looking like a square box here. Each box, each division is again subdivided here. It is shown here. So it is again subdivided into number of parts here. Total 5 parts are made in each division. So 1 by 5 will be equal to 0.2. So first this one along x-axis, if you take, this is 0.2, this is 0.4, this is 0.6, this is 0.8, this is 1. If you take along y-axis, this will be 0.2, 0.4, 0.6, 0.8, 0.1 it is. So this is how we can make use of this here for the measurement of signal amplitude as well as signal time here. So suppose if I consider 3 different cases here: sine wave with different amplitude and time, square wave. So how to measure amplitude and time in the CRO with the help of an example. So let me explain you. So first, so this is one sine wave pattern I have considered here. So you can see here, for sine wave, it is a continuously repetitive signal. So for measurement, we should consider only one full cycle. So in one full cycle means this, it contains one positive half cycle and one negative half cycle. So this is one cycle here. So this, for one cycle we are going to measure the time period. So this is the time period for which one cycle we are going to measure. So the amplitude, how it is taken, peak to peak. Peak to peak we are measuring the amplitude. So this is the positive peak, this is the negative peak. So peak to peak, how many divisions are there? 1, 2, 3, 4. So this peak to peak is having 4 divisions. So 4, it should be multiplied with the voltage division per division. How much voltage we have kept here. Suppose if the division is 2 volts, one division is equal to 2 volts, or one division is equal to 5 volts, that should be multiplied with this number of divisions V peak to peak. So for example, suppose if I have kept the actually the one division is equal to 5 volt, in this case it is having actually 4 divisions. So 4 into one division value is 5 here. So this comes is equal to 20 volt. Totally amplitude is peak to peak, it is 20 volts. So that I can write it in the tabular column here. So for sine wave, first example, so it has total 4 division and each division is equal to 5 volt. So that is equal to 20 volts. So next sine wave pattern I will take. So this is the next sine wave pattern. So in this case you can see here, so this is also measured from peak to peak here. So this is the positive peak, this is the negative peak here. So peak to peak measurement is done here. So you should measure the number of divisions first. So this contains 1, 2, 3, 4. Above 4 it is not complete 5. Above 4 it is having some subdivisions here. So after 4 it is this, here I can take it as 0.2, 0.4, 0.6, 0.8. So 4 plus 0.8. So 4.8 division it is having. 1, 2, 3, 4. 4.2, 4.4, 4.6, 4.8. So 4.8 division it is having. So I will take it, I will write it here, 4.8 division. Suppose if the division here, if the division, if it is kept at 2 volts in the volt division in the CRO, then I can take that division value here, one division value, suppose if it is 2, then it is equal to 9.6 volts. So this is how we can measure the amplitude. Now I will take the square waveform for example. So square waveform you can see here. So one pattern I have taken here. So from this you can see the peak to peak amplitude. So this is positive peak, this is negative peak. So peak to peak amplitude is, if you take the number of divisions, 1, 2, 3, 4. Total 4 divisions it is having. So that one you write it first. So it is having 4 division, 4 into, suppose if each division value from this voltage division knob, suppose if you have kept it at 10, one division is equal to 10 here. So it is having 4 division. 4 into 10 is equal to 40. So this one you will understand when you are observing in the CRO. So this is clear. Next is time measurement. So how to measure the time from the waveform. So here let me consider the first case, that is the sine wave. So in this case, how we are measuring the time is along x-axis. So for time measurement we could take one complete cycle. So this is one complete cycle. After this, the same cycle, after this here from this point, the same cycle will repeat. So up to this, from 0 to this point, we have to measure the time here. So the time is also measured similarly as we have measured for amplitude, but here it is taken along x-axis. So the total number of divisions we have to take here. So this one cycle is having 1, 2, 3, 4. So 4 divisions it is having. Suppose if each division value here, if each division value is kept here at 1 millisecond, then we have to write the time is equal to time for sine wave. So we have 4 division along x-axis into, if the division value is 1 millisecond, then is equal to, it is 4 millisecond. So this is how we can measure the time for sine wave. Suppose if I take the next sine wave, then how the measurement is done here. The second sine wave here, you can observe the total number of divisions. I think it is also same. This is one full cycle, one complete cycle. So total number of division is 1, 2, 3, 4. So 4 into, suppose if I have kept the time knob at some other value, one division is equal to 2 millisecond or 5 milliseconds. So let me take 5 millisecond. In this case, how to calculate the time here? So in this we have same 4 divisions, but the each division value, if it is 5 millisecond, then is equal, this will be equal to 20 milliseconds. So this is how the time is calculated. Next, let me consider square wave here. Square wave, how the time is taken here. So this is also taken for one full complete cycle. So this is the positive cycle, this is the negative cycle. So here it ends here. So it starts from this point, it ends here. Again the same cycle will repeat here. So only for this we have to take the time period. So let me take the total number of divisions here. This is 1, this is second, this is not full complete 3 cycles here, 3 divisions here, 1, 2, next is 2.2, 2.4, 2.6 it is. So 2.6 divisions it is having. So let me write it here, 2.6. Suppose if it is if we have kept the time knob at 10 millisecond in the CRO, then that each division should be multiplied with 10 millisecond. So this comes is equal to 26 millisecond. So this is how we can calculate the time from the CRO. Next is frequency calculation. So by using this formula, F is equal to 1 by T. So what the time we have measured here. So here we can calculate the frequency. So F is equal to, in this case, for this it will be 1 divided by 4 millisecond. So that we should calculate, and that should be verified with the function generator frequency. So it should match approximately. So this is how we are measuring the amplitude, time as well as frequency from the CRO, and we are verifying with the function generator frequency for our understanding here for the verification. I think it is clear for you. Thank you.